All right, so we are now doing integration with u substitution. So we are looking at maybe the larger, more difficult piece of it, seeing how that would be as a derivative, and then seeing if we need to take anything else into consideration. And so if I look at this first one, if you were to use substitution, hopefully you recognize that the derivative of this would actually equal that 5x to the fourth. And so you don't have to really make any changes. You can just say, well, I just have to consider what happens when I integrate that versus wondering about any extra pieces that I need to do. If you were to use u substitution here, you could say that u is x to the fifth plus 5, and that the derivative of u then would be 5x to the fourth dx. And you can see that every piece is accounted for. And so you can say, well, I'm just now integrating u to the fifth then. Because u to the fifth takes care of this to the fifth, and du takes care of the 5x to the fourth and the dx. And so that antiderivative is really simple. That's just going to be add 1 and divide by your new derivative plus c. And then, of course, we do have to put our substitution back in, put that in for u. So we have 1/6 x to the fifth plus 5 to the sixth plus c. And so when it works out all nice and pretty, when you have all your pieces accounted for, you're really done. But there can be a situation like number 6, where if I were to do u substitution here for number 6, my more difficult one is going to be that 2x cubed minus 1. And so when I take that derivative, I actually get 6x squared dx. Well, I don't want 6x squared dx. I want 18x squared dx. So for this one, I actually have to multiply both sides by 3 to get that 18x squared dx, which is what I want. And so now, when I rewrite this, so instead of just doing my u du, I have to count for this 3. And so I'm going to put that 3, multiplying it. And then I have u to the negative 5 because it's in that denominator, du. And I have accounted for every piece. My u to the negative 5 takes care of this. My 3 times du takes care of the 18x squared dx. So I've replaced every piece. And now, once again, I'm going to take the antiderivative 3 times my new exponent when I add 1 is negative 4. And then I divide by negative 4 plus c. Then, of course, I have to negative 3/4. And actually, because that is a negative exponent, I'm going to actually do negative 3 over that 4 and go ahead and put this in the denominator when I replace that u. 2x cubed minus 1 to the fourth, and of course plus c when I replace that u back. So I just multiplied the 3 times the negative 1/4, that's negative 3/4. U to the negative fourth, that's actually u to the fourth in the denominator because it's a negative exponent, and I just replaced my u there. All right, so for this one, it's a little bit different because obviously my more difficult one is the 2x plus 3. And so I am going to do u equals 2x plus 3. My du here is just going to be 2 dx. Well, I don't need a 2, I need a 5. So the first thing I have to do is I have to multiply by 5/2 to get that 5. But I'm also missing an x. So I have my 5 and my dx, but I do not have my x. And so I have to go back up here and write this in terms of x. So if I say u minus 3 divided by 2, that equals x. All right, so I have to make sure I have accounted for every piece of it, okay? And so now that I've accounted for every piece, the 5/2 du are going to account for the 5 dx. U to the 1/3 will account for this guy right here. And then the u minus 3 over 2 will account for the x.
That's just a big.
And so I have accounted for every piece. And we're going to simplify it. All right, this denominator here is just like multiplying by 1/2. So I'm actually going to pull that 1/2 over here. So I'm going to multiply 5/2 by 1/2. So I'm going to make this 5/4. And then I have u minus 3 times u to the 1/3. I'm actually going to distribute that through here. So u to the 1/3 times u to the 1 is u to the 4/3 minus 3u to the 1/3 du. And now I can do my antiderivative. Leave that 5/4 out here for right now. My new exponent is going to be u to the 7/3 times 3/7, always divide, minus u to the 4/3 times 3/4. So this is actually going to be what, 9/4 plus c. And I think they, in the answer key, just distribute that through when they replace it. So 5/4 times 3/7, that's 15 over 28. And instead of u, I'm going to replace my u, 2x plus 3 to the 7/3 minus, distribute that 5/4 through, 45/16, replace my u, 2x plus 3 to the 4/3, and then don't forget, this is indefinite right now, plus c. When I look at this one, you can think of this guy right here as sine of 5x to the 5th, okay?
That's probably correct.
So when I do my u here would be sine of 5x. And my du would just be cosine of 5x. But we do have to do our chain rule. And so we have cosine of 5x. Then times the derivative of the inside, so times 5. So we have 5 cosine of 5x. We don't want 5 cosine of 5x. We want 15 cosine of 5x. So we do have to multiply both sides by that 3 to get the 15 cosine of 5x. And so we've actually accounted for everything here. The 3 du will give me the 15 5x dx. And the u to the 5th will give me sine to the 5th, sine of 5x to the 5th. And so I really just have to do, 3 times. My new exponent is 6, and then of course I'm dividing by 6, plus c. I do need to simplify this. 3 times 6 is 1/2. Replace my u, so it is sine to the 6th of 5x plus c. The last thing we're going to do is definite integration. The only difference between this and what we've been doing is you can plug the numbers in at the end. But remember, you can plug them into your u and just change your bottom and top, right? And that's usually easier. So, and what I mean by that is instead of having to go back and replace your u with your group, you can replace your numbers at the beginning and leave your u alone and just replace that with your new numbers, because that's what it would equal if you plugged in your old numbers. So I'm going to pick out my u just like I would before. My u is going to be 4x squared plus 4. My du is going to be 8x dx. I do not want 8x. I want 16x. So I do need to multiply by that 2. And I've really accounted for everything. My 2 du accounts for the 16x dx. And my u to the negative 2 accounts for this. Now, instead of using 0 to 2, I am going to find new boundaries by plugging them into my u. So if I plug in a 0 here, I get 4. That's going to be my new lower boundary. And if I plug in a 2 here, my new upper boundary will be 20. All right? The reason I do that is now I don't have to replace my u when I'm done with integration. I can now just plug it in, because if I replaced my u and plugged in 0 and 2, it would be like plugging in, you know, those numbers, because that's what happens when you plug them in. So now I just have to take my integration. So 2 times my new exponent is -1, and I have to divide by -1 or multiply by -1. And I'm doing that from 4 to 20. All right. Now, remember, so multiply that 2 and -1. So -2 over u from 4 to 20. All right. So plug in a 20. So -2 over 20 minus -2 over 4. So I have -1/10 plus 1/2, which is 5/10, right? So common denominator would be 5/10 here. -1/10 plus 5/10 is 4/10. Of course, I want to reduce that to 2/5, which is my answer here.